Welcome to all. Today I am starting moment of inertia of a circular area or circular cross-section of a member or circular lamina or area in the form of a circle. About its centroidal axis, see, plural, lying in the plane of the area. See, the circle is here, centroidal axis in the plane of the area. Okay. Let D be the diameter. See here, D is the diameter. Let R be the radius. See, this is a radius. Anywhere you can mark radius, either here, or even here also you can mark. See, that I don't have to tell. If this is D, this is R. Surely radius equal to diameter by 2. Now, let G be centroid for circle. Now, you already know for a circle, centroid G coincides with center of circle, say C. So, if I call this as center of circle C, the C and G both are same. See, this is C and also G. I already told it earlier. C or it is also G. Okay, centroid G. Let us find moment of inertia I about XX and YY. Class, you write something. We will consider a horizontal axis passing to centroid, say XX, a vertical axis passing to centroid, say YY. Here, even if you consider inclined also, same answer. But usually we want XXYY. That is IXX, IYY. Now, up to here standard. Okay, now, there are two options are there. Option 1 is considering a small arc, radial distance r, angle theta, subtended angle d theta, the way we did for centroid earlier, long back, centroid for circle or semicircle or quadrant. That is option 1. Option 2 is something special. Actually, make a note. Option 2 is very, very easy. It is not wrong. But of course, there is some extra option 2. We have to use some logic. Option 1 will give you directly, see, you can write here, option 1 will give you directly IXX, IYY. But option 2 will not give you IXX, IYY. It will give you I about, see, the perpendicular axis. Once you get that I using perpendicular axis theorem, you can get IXX, IYY. So, actually I should do option 1 first. Once I finish option 1, I should go to option 2. Easy method. But I am going for option 2 first. Again I will tell why in the class I will tell now. You write here. Because option 2 is very simple and we are using it for circle. That's all. Now, option 1, the way we have done in option 1, that is the way we considered in centroid. There it was option 2, no doubt. It was option, that is no problem. That don't bother. There it was option 2. Because option 1 was something else there. You don't bother about option 2. Option 2 is the way we considered earlier in centroid. I will tell you later. There, that is actually where you directly get IXX, IYY. And one more thing is that one, if you extend further, you will get I not only for circle, you write there, in the option 1, you will get moment of inertia not only for circle, but also for a semicircle about its diameter, and also for a quadrant of a circle if the axis passes to center. So, what I write on the board, using the limit of changing the limit of integration, you can cover in single step circle, semicircle and quadrant. Therefore, what happens now? If I write option 2 first here, see, I have rubbed other things all. And tomorrow's class, next class, is moment of inertia for semicircle and quadrant of a circle about centroidal axis. So many people lot of people get confusion there. When to use that pi by pi d power 4 or some decimal numbers are coming. I will make fully clear with the correct logic and reasoning also. So, what I conclude in option 1 today, I will maintain in the board as it is. I will not rub it. Tomorrow's class, next class, when I start, I will show that display once again on the board. And I will tell, remember, this was yesterday's result. Now we are extending further for semicircle and quadrant. Therefore, if I write option 1 first, then what about option 2? I have rubbed the board. So, to see that your option 1 is required for next class also, I am first doing option 2. Okay. Option 2, what you do is, make a note here. In option 2, directly you won't get IXX, IYY. See, this is circle. See, this is XX axis. Don't mark XX. This is YY axis. One thing you remember now, I should not tell this way. If you consider XX axis, see here, I should not tell. If you consider, you should make a note. If circle is in black color, okay, see. If you consider a circle, see, this way, and mark XX axis here, then all your distance will be vertical. You consider vertical distance. Okay. Or if you consider a circle and if you mark YY axis, all distances will be horizontal. This you know it. How many times I told? From XX, you go vertically up and down. But this way we are not doing. We want moment of inertia about perpendicular axis, or we are going to consider a circular elemental strip. See, when I take a circular elemental strip here, this way, you cannot consider XXYY because it has a reason for you only. Consider elemental circular strip. See here, very, very thin elemental circular strip. Actually, circle is not very neat here. Adjust it. Elemental circular strip of thickness dr at radial distance r from center. R is a variable. See, capital R is for full radius. This is small r. See, if I come here, it's small r becomes capital R. If I am considered here, small r becomes 0. You know it. So this r is a variable. At radial distance r from where? See, it is not from XXYY because, see reason here. You cannot take, see one more thing is there. When you consider distance as radial distance r, see, when you take radial distance r, it is distance from a perpendicular axis. See, here I can't show that way. It is actually, I wrote CZ here. Actually, CZ is like this. I cannot show. See here, this way. If I take this axis, see now, wherever you are in the strip, radial length r, see, radial length r, radial length r, radial length r, radial length r. For the complete strip r, because when you integrate elemental strip area dA, you take at y, then what you do? Usually, see, you take a strip here and at y from here, for everywhere in the strip, y should be constant or same. But here, xx you cannot take because, see the reason here. You write all this one. If I consider xx axis by chance, see, xx axis, if I take a elemental strip this way, see, this is distance. When you come here, distance reduces. Here, distance 0. Here, distance 0 it becomes. So, see, if this way you consider a strip, radial distance is r, perpendicular. Therefore, r you can make out. Everywhere in the strip, for entire strip, all around the strip, wherever you stand, distance should be constant. It is not constant from xx. See, distance varies. It is not constant. See, yy. See, more. It becomes lesser and lesser. It is constant or constant value only with respect to, see, this axis. See now, r, 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 r. That's why in this option 2, we consider elemental strip of thickness, so elemental circular strip of thickness dr, see, I wrote here, of thickness dr at radial distance r from center, or at radial distance r from CZ axis. See, center means from an axis passing to center, but actually even if I wrote this way, see, axis is like this. From CZ axis, that is CZ axis, which is perpendicular to plane, CZ is perpendicular to plane and passes through center of circle as shown. Okay, you can either call CZ or OZ. Suppose you don't like CZ, you can do one thing. If I call center as O, suppose center call O, you write OZ. But usually center we take C, therefore CZ. Okay, CZ or OZ or ZZ. See, this way, ZZ. Okay. Class. Therefore, one note you are right. Since you are taking distance r from OZ, CZ axis, you will get moment of inertia about CZ axis now. Your moment of inertia will not be XXYY, you will get about the CZ axis. That is the axis perpendicular to the plane passing to center. Okay. Now, class, derivation purpose, radius r. I already told you, for circle or semicircle or quadrant, when you derive, you usually consider radius capital R. But later, when you apply it, we always write in terms of diameter in structural engineering. So, already explained earlier. Should not tell. So, we will derive with respect to capital R, radius of circle. Then later we will replace that R by d by 2 and then get the answer in terms of diameter. By chance in examination, if they ask, find moment of inertia for a circular area of diameter d, no problem. You write, let R be the radius. You solve in terms of radius. Then replace R by d by 2. They cannot object for that one. You can tell them, okay sir, you want diameter? No, I will, because my distance is from center. Now my variable is from center. I will solve with respect to radial length R. Later I will replace R by d by 2. Okay, done. Okay, now let dA be area of elemental strip. See, for this complete strip, area is dA. Thickness is dr. See, when it is R, thickness should, I don't think, I'll put dr here to make it more clear. See, when you write variable R, thickness should be dr. Like, if the variable is y, thickness is dy. If the variable is x, thickness is dx. That way, since you go where you are going for, see, green color is variable. When you go for variable R, small length is, see, this is called R. A very small length is called dr. So let dA be area of elemental circular strip. How to get it? See, one note. Directly right here. dA equal to directly circumference of elemental strip. Either you call circumference or call perimeter, anything, or perimeter, multiplied by dr, thickness, multiplied by thickness. Why? See, it is circumference of this elemental strip into dr. Somebody will ask why. Do one thing. Make a note. Somewhere cut here. Stretch it. What will happen? If you cut here and stretch fully, either horizontally or vertically, space is there. See, if you stretch, it will become a strip like this. See, thickness is dr, and if you cut and stretch, this total length will be equal to perimeter. Or whatever is circumference here. See, suppose the circular rope is there, this way. You cut and stretch, what will happen? The length of the rope will become what? Circumference of a circle. That much common sense language required for engineers. Okay. Therefore, now remember, circumference of a circle, I should not tell. Somewhere right here, actually not required. See, circumference of a circle equal to, if you want in terms of radius, it is 2 pi r, 2 pi into radius. Or if you talk in terms of diameter, it is pi into diameter. But we are taking radius, so use radius. So therefore, circumference equal to 2 pi, see, I want circumference for elemental strip, radius is r. 2 pi r is the circumference into thickness is dr. 2 pi r dr is area of the elemental strip. Now see, so simple it is. You can make out 1 minute now. I can remove this one because this is not required now. Okay. Option 2. Option 1 I will come later. This I still want it because why? I want for second case, other case. Right. We got area elemental. Therefore, moment of inertia of circular area, entire circular area of entire circular area about which axis? Moment of inertia will come always about the axis from which this variable r is considered. We took r from CZ axis, about your CZ axis, or that is ICZ, CZ or OZ or ZZ, whatever you want to call. You either call CZ or Mark Centresco call OZ or simply call ZZ, whatever you want. CZ axis equal to, now same thing, integration of dA into r square. Why? Basic mathematics. Integration of elemental area into variable r square integration. Now limit, see, make a note. Your strip should cover the complete circle. You take r. This strip will come down. Starting is 0. Starting from r equal to 0 to maximum r equal to capital R. This already I told you earlier. Or if you drop a stone to water, what will happen? Initially, radius is 0. Radius will keep on expanding that way. See, the moment it touches the water, 0 radius, then slowly circle will start coming. See, it will come this way. Circle will come. That you know it. Finally, full radius. Okay, equal to integration of dA 2 pi r into dr is 2 r is a variable. 2 pi r is variable into dr is the elemental area into r square. How much? 0 to r. 0 to r. Or equal to, I can take 2 pi outside, integration 0 to r of r square into r is r cube dr. R cube dr, or this will be equal to 2 pi into r cube becomes r power 4 divided by 4 from 0 to r, or equal to 2 pi into capital R power 4 by 4 minus 0, or equal to 2 pi into r. How much it is? Pi r power 4 divided by 2. 2 and 4. 2 times 4. So it is pi r power 4 divided by 2. This is your ICZ. This much you get first. Once you get this answer, see now what to do. Okay, I will remove all this one now. This also I will remove. See, this I will remove now. Not required. Required? No, not required. Now, see, we got I about which axis? The perpendicular axis. So now, by see, now make a note here. We got ICZ, but we got, see, we got I about Z axis, but we want what? We want I about XX and I about YY. Okay, no problem. Right here. We have by perpendicular axis theorem. Perpendicular axis theorem. Axis theorem. See, moment of inertia about an axis perpendicular to the plane passing to any point, here passing to center. ICZ equal to sum of moment of inertia about two mutually perpendicular planes lying in the plane, that is xx and yy, equal to ixx plus iyy. Ixx plus iyy. But remember, ixy, but I about xx is equal to I about yy. Why? Because circle, whatever I you got about xx is equal to I about yy. Therefore, 1 minute now, I'll substitute here. Therefore, substituting, this is pi into r power 4 by 2 equal to what? Ixx plus iyy. Right here. But we know that I about xx is equal to I about yy. Why? Circle. See, xx, yy, whatever you consider, say even if you can take inclined also. Equal. When both are equal to what? Pi r power 4 by 2 divided by 2, or equal to pi r power 4 by 4. Why divided by 2 is I can't answer. Such a silly question. See, suppose x plus y equal to 10. If x equal to y, then what happens? Then x equal to y means both of them will be equal to 10 divided by 2. That is very common. If this step is not clear, subject cannot be understood. Ixx equal to iyy, both are equal. So therefore, any one of them, both are equal to whatever is the total answer divided by 2. Okay. Right. Therefore, summary. See. Therefore, pi r power 4, I about xx equal to iyy, or, right, now, in terms of diameter, what to do? Replace r by d by 2. Then your ixx equal to iyy equal to pi into r d by 2 power 4 by 4, or equal to 2 power 4, 2 into 2 4, 4 into 4 16, 16 4 is 64, pi d power 4 by 64 is the answer. Therefore, as per your second option, of course I solved first. Second option, final answer is what? Final answer is, if there is a circle, see, if there is circular area, see, final result I will write here, result of diameter equal to d or radius equal to r, anything one you can take. Then this is the center, see, center of the circle, come centroid G, both are same. This is the xx axis, horizontal centroidal axis. This is vertical centroidal axis, yy. Then the answer is what? Then the answer is, I write here now, I about xx equal to I about yy, or you can write I about any diameter. See, I about any diameter, also will do. Diameter equal to, in terms of radius, we got pi r power 4 by 4. This is in terms of radius. R, or equal to how much? Or you can write r equal to r pi d power 4 by 64. This is in terms of diameter. Remember, derivation we got using radius, but remember, this is we are using for all further calculation. When you do problems, We always write, nobody will write pi r power 4 by 4. Radius, nobody writes. In entire structure engineering, when you want moment of inertia for a circle, people write pi d power 4 by 64. Okay. This is the result from option 1 or option 2. Actually, I should have done option 2 afterwards. But option 1, what I am doing, that final sketch I want for next class. Therefore, I first finish option 2. Now go to option 1. See. So option 1 means, see, I'll tell you what the option 1. Everything over. See. Now, best option is, see, to understand correctly, the best option I will tell you. Those who are serious in studying, what they should do is, they should write everything systematically. Then only it will be clear for them, not randomly writing something like that. Those who are serious can do one thing. That is, I hope everybody is serious. Write once again start. Once again start from here. Start from here. Moment of inertia of a circular area about its centroidal axis lying in the plane of the area. Let d be the diameter, r be the radius, r equal d by 2. Show diameter d, show radius r. Centroid C will coincide with centroid G will coincide with center of circle, and G will coincide right here. Let us find moment of inertia I about xx and yy axis. That is, we require ixx and iyy. Now I will go for, then write option 1. Option 1. This something is there. Class. I will put the sketch and start. 1 minute. Option 1, something I have to tell. That's why I will see space is there. Later, I will remove this one. If I want space, this I will remove. Okay, I will start now. Now I will continue. Same I told, all the statement right once again. We require ixx, iyy. Now we are going for option 1, class. See, make a note, long back in the centroid, part 3, lecture 13, same thing is told. I went through a video once again. The video means, okay, in YouTube it is video, but actually just now I gone through that one, and what all I wrote here, I copied same way here. Why? Because that day I told you, same thing you require later for moment of inertia, and I told at that time, I will not explain. I will tell you, go back to centroid class and then study and come back. So you go back to part 3, lecture 13, timing is 3:23 onwards. Up to 3:23 something else is there. 3:23 I started explaining this one. See, one thing now, see, this circle does not look like a circle. Freehand I cannot draw here. I tried I tried this way. Don't make issue of those things. Okay, now correctly observe how to solve now. See, what all I told on that class is, see, first of all, at that time I told later for moment of inertia you require. So therefore at that time same, everything same will come. I told at that time, today I will explain each and every concept. See, this small length, angle, theta, what is d theta, what is r, what is y, all I explained on that day. Then I told, when you go to moment of inertia class, you come back here, study and go back. Do that one. But anyway, I will briefly explain. See, consider elemental strip. See, a small strip. Remember, in the form of an arc. Arc of a circle. You write here. Arc means what? Understood, right? Arc of a circle. What else? Arc of a circle. Understood. Arc of a circle at radial distance r. See, from center. At radial distance r from center. So from center, it is radial distance r. See, from here to here is r. Since this is variable r, thickness should be dr. Very important. See, if the variable is y, thickness is dy. If variable is x, thickness is dx. When variable is r, thickness is dr. So, okay, then further, let ds be arc length. See, this arc length is ds. And for the small r, angle subtended at center is d theta, small angle. See, this is d theta, the small angle. This is d theta means from here you take theta. See, the arc actually it is, I told you, see, if you write somewhat, see, actually how it will be? Very, 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 very small. So, see, this is theta. That is d theta and ds all, you cannot see it. And this is your y later. So, this, see, from here to the arc, let the angle be theta and then move by very micro small distance by d theta, angular here. And let the height of the, I wrote somewhere, okay, 1 minute. Let ds be arc length of elemental strip. Then let theta be angle made as shown in figure. Theta. That is for the strip from CB axis, see, in the anti-clockwise direction. Let d theta be the angle subtended at center C by elemental strip. Let dA be area of elemental strip. See, this area equal to dA. dA is the area of elemental strip, understood. That much you can make out when I took a small area here and when I tell, see, there is no space to write here. This area equal to dA. You can write here, dA is area of elemental strip. Then let y be the vertical distance of this elemental strip from AB axis. See, you consider an axis AB here. See, AB is the diameter. Remember later this AB itself is your XX. Be careful, I won't tell once again. Later, whatever AB you called here, that itself is XX for circle. But it is not XX for semicircle or quadrant, because see, if it is circle, what you called AB here itself is XX. See, that itself is XX. See, correct, clear. This all you are right. See, that itself is XX axis. Both are same. But if you consider semicircle, see, if you consider semicircle, what AB you call is not XX, because semicircle XX will be here. See, centroid is here. Or if you consider only quadrant of a circle this way, if you call this axis as AB for the quadrant, this AB axis is not XX, XX is here. So for circle, this AB itself is what? Itself is XX. First you will do circle, then you will go to semicircle and quadrant. Okay, I'll remove this one now. This space is wasted. Okay. Now, I will do one thing now. This much is clear. I want some space. Since I want some space, I will remove this one now. See, bottom side I will remove. See, I want writing here. See, I will remove this one now. Okay. It is removed. Okay. But remember, one more thing is there. Before I remove, I will tell one thing. See. Okay. Before I remove, our variable later is going to be theta. Theta and r. Theta and r, small r, are our variable. Even though y is the variable here, we will convert that y, see in the class, that y we will convert in terms of r and theta, and even ds also we will convert to r and theta, r and d theta rather. Okay, then how your theta varies? See correctly now. If you take a full circle, see, full circle, your theta will vary from 0 to 2 pi radians, because remember, whenever you do integration or differentiation, or when you use arc length equal ds equal to r d theta, it is a rule that theta should be in radians. Degree is not allowed. 2 pi radians. That is the variable for theta. Remember, variation for theta is 0 to full circle, 2 pi radians. Okay. Little later, when I go to semicircle, now I will remove this one now. Circle is 0 to 2 pi. When I do semicircle, the variation of theta is 0 to pi radians. 0 to pi. Okay, semicircle. And when I take quadrant of a circle, the theta variation is 0 to pi by 2. That all I will explain later. That's why I wrote second time. Now this sketch I want, this space I want. So make a note in the class. Bottom I removed here. In the class I will tell you, class, that y, you replace y in terms of, get y in terms of r and theta, and even your ds also should be in terms of r and theta, and dA also in terms of r and theta or d theta. Okay, start. First do that one. I will remove this one now. First, this all I will remove now. You write all this one. First y. Sin theta equal to y divided by r. Okay. Green color, 1 minute. Sin theta equal to y divided by r. Therefore, your y will become, I'll write here, your y will become r into sin theta. One result, 1 minute. Somebody will ask, sir, there is small things are there. On that class I told small things are not there. Actually, if you write a real sketch here, it is how very small. R, y, theta. Sin theta equal to y divided by r. D theta, ds, dr are very small. You cannot see it. It is micro. So, see here. Sin theta equal to y by r, y equal to r sin theta. And everybody who knows mathematics should know arc length ds equal to radial length r into theta, into d theta. See why? The formula is what? Arc length equal to radius into angle subtended by the arc here at center, r into d theta. One more result. This I explained there. And lastly, y equal to r d theta, y equal to r sin theta, ds equal to r d theta. Okay, now this much you write. Now, once this much is over, remember now, from here, this d theta is giving trouble to me. I will write here r. I will put d theta here. This is d theta. Some space problem is there here because I want to show one more thing. D theta, and from here to extreme fiber here, this is radial length, radius of semicircle r. So later remember, your r will vary from, this is your radial length r. Radial distance r will vary from 0 to r. Remember, variation of r is from 0 to what? 0 to r. You remember that one. R varies from 0 to r, whether it is circle or semicircle or quadrant, whatever is there, this r will vary from 0 to r, but theta will vary whether you consider full circle or semicircle or quadrant. Okay, this much you write. Then, right here. First, ds over elemental area dA. Elemental area dA equal to, see here, this small rectangle here, it is ds into dr. Why means I can't explain. See, this is a small strip here. This is ds, this is dr. But therefore, ds equal to what? R d theta. Therefore, your dA equal to r d theta into dr. So therefore, your dA will come how much? Right here, dA will come r into dr into d theta, r into dr into d theta, or r into d theta into dr. dA equal to r into dr into d theta. I will write r first because when I integrate, I will first integrate. I don't remember how I integrate. I'll check that in the calculator. I'll check it. Not calculator, sorry. In my mobile, I'll see there whether I integrated r first or theta first. Accordingly, I will change. I think it is r first and theta. Yes, it is r first and theta. So I will interchange dA equal to r into dr into d theta. Same thing there also most probably. Okay. This I will remove. Now, at that time, I wrote y bar equal to integration of dA into y divided by area. That was the step after all this calculation. Of course, it was for semicircle, not for circle. Because why? Anyway, circle you cannot see. You see this side. This is the statement for either semicircle or quadrant. Circle we don't do this way. Because circle centroid lies at center only. But here, not that way. Right here. Therefore, now we want moment of inertia. See, therefore, moment of inertia of red color I'll write. Red I can't write because I am not doing centroidal axis. I want to use red color. Therefore, see, I'll short form moment of inertia of elemental strip. Elemental strip should be green color as per my usual format of elemental strip about which axis? See, about AB equal to dA into y square. dA into y square. Why? Area into distance from y is y, right now y square, or equal to, go further, dA equal to r d theta, d substitute equal to, again green is not coming, okay, but replace, see, you know that dA, substitute dA, r d theta, r dr, okay, equal to r dr into d theta, that is dA into y square is r sin theta whole square, r sin theta whole square, or this is equal to what? r square into r cube into, see, r square into r is r cube into dr into d theta. dr into d theta. This is moment of inertia of elemental strip. Now see careful. See, this much statement is over. Now I will write here. Now I want more space. This full I will rub and write one by one. Okay, I write here only, not much. One minute. Okay. This space also not required. This also not required. Okay, this also you can understand. Those who are serious will study. Those who are not serious, what I can do? I told them study correctly, for refer to old one. See, these are all finer concepts. You should study thoroughly. Okay, dA into y square. See, already I wrote here. Oh, sorry, I already wrote full format. Okay, no problem. This area of elemental strip out, moment of inertia, I already wrote it, but I'm writing once again. Okay. Therefore, see, therefore, we are now doing the question for what? Circle. You show in the sketch. See, in the sketch, full circle should be there. I removed it. Therefore, moment of inertia of entire circular area about AB, that is IAB for a circle, that AB itself is x axis later, equal to integration, double integration. Tell why? It is double integration because there are two variables. This I told you earlier. The same thing in centroid add-on. Two variables. One variable is r, one is theta. So it is r square into dr not r square, r cube, r cube, little bigger I will write here, okay, equal to, see, integration, double integration of elemental, see, this is for elemental area, r cube dr into d theta, see, r varies from 0 to r varies from r, I told you. This is permanent now, see, irrespective of full circle or semicircle or quadrant, radial length varies from 0 to r, but theta varies from, we are right now doing for circle. Circle means, see, one full round is called 2 pi radians. Theta varies from 0 to theta equal to 2 pi radians. Theta equal to 2 pi radians. 2 pi radians. Dr d theta or equal to, see, do one thing. Integration of r equal to 0 to r equal to, r I will still maintain same, r equal to 0 to r equal to capital R of integrate, see, do one thing, dr you write last, see, r cube d theta, how much it is? R cube is, r cube, what is the answer there? R cube into, see, r cube into d theta. Where is, d theta into, see, major mistake here, equal to r cube into sine square theta. Okay, sine square theta into dr into d theta. Okay, forgotten. R cube into, see, sine square theta into dr into d theta. What I will do is, r I will push outside. I will first finish integration. R cube, see, r cube into this, r cube, okay, r cube into, 1 minute, integration of how much? Theta from 0 to theta to 2 pi radians of sine square theta, okay, again green color required, okay, of sine square theta times d theta after everything is over with respect to dr. See, you finish, you can do one thing, you can write here r cube, use a bracket here. I don't know what format I wrote there. This is theta integration. See, this is your theta integration. This is your r integration. Okay, start. Now, wait 1 minute. Some mathematics you require. Before you go further, see, now, make a note. See, somewhere, okay, here only. See, we have mathematically sine square theta equal to, everybody should know. See, mathematically, if this is not known, I am helpless. You should know that sine square theta equal to 1 minus cos 2 theta by 2. 1 minus cos 2 theta by 2. Therefore, I will remove this one now. Sine square theta is 1 minus cos 2 theta by 2. That is the mathematics. This I can't explain in the class here. Mathematical equation of trigonometry, you should know it. That cannot be explained in the class here. Okay, this full I will remove. Some space is there here. I will complete now. Then summary required, I will write there. 1 minus cos 2 theta divided by 2. Okay, 1 minute. Becoming little, because of the small things, it is becoming little what? Not confusion. See, people have to study thoroughly. Therefore, your IAB becomes, for entire circle, becomes integration r equal to 0 to r equal to capital R. That will not permit. Camera checking. Should not go above the camera limit. After everything is over, when I upload the class, okay, see, when I finally upload the class, if this happens, so bad, r equal to r of, see, r cube, see here, r cube, and then bracket, integration, theta equal to 0 to theta equal to 2 pi radians of sine square theta is 1 minus cos 2 theta by 2 times d theta. Once this integration is over, r cube into dr. Okay, sufficient. Now I can integrate happily and get the answer. Okay. Now I remove all this one. Correct answer, r cube 0 to r, theta equal to 0 to theta equal to 2 pi of sine square theta is 1 minus cos 2 theta by 2 d theta into r. This should be green color theta. See why? Because format. Theta should be green color 2 theta. Okay. Okay, everything is over now. I'll remove this one now. That's all. Now I hope no problem. Okay, start. Equal to, see here, integration r equal to 0 to r equal to capital R of r cube. So I forgotten. R cube will remain here only. R cube times, okay, start. Integrate. 1 by 2, see, 1 by 2 into, nothing is there. Nothing is there means theta. See, when you integrate a constant, 1 by 2 is actually, constant becomes constant into theta. Then minus, integrate cos 2 theta. Integrate cos 2 theta becomes minus of, integrate cos 2 theta. Cos 2 theta, when you integrate, it becomes sin 2 theta. Minus sin 2 theta divided by, or you can do one thing, you take that half outside, better. It is better to take half outside, still better. See, you take this half outside into half times, okay, start, half outside, 1 becomes theta. 1 becomes theta. Minus cos 2 theta becomes sin 2 theta. Sin 2 theta. But remember, when you differentiate, if it is sin 2 theta, you have to multiply by 2. When you integrate, you have to divide the coefficient of theta by 2. Divide by 2. This 2 is not this 2. This 2 has already gone outside. This 2 is cos 2 theta, when you integrate, is sin 2 theta by coefficient of theta 2. Limit is 0 to what? Here limit is 0 to 2 pi. When you finish that one, outside dr or equal to, see, integration r equal to 0 to r equal to r of r cube by 2 times, put upper limit, theta equal 2 pi. 2 pi theta minus 0. This is upper limit. For theta, upper limit minus lower limit. Then outside minus bracket, sin 2 theta becomes what? This 2. 2 is also there. Sin 2 theta becomes sin, see, 2 theta, 2 into 2 pi divided by 2, which 2? This divided by 2, minus sin, lower limit is 0, 0. Okay, close the bracket into dr. See, theta becomes upper limit 2 pi minus 0 over here. Sin 2 pi by 2, 2 by 2 is already there, or you can do one thing, this 2 half you can take outside also, that is better. Okay, that's still better. take that half outside, one more half outside, half times sine 2 theta becomes sine 2 into 2 pi. You can write here directly sine 4 pi minus sine 0. Sine 0. Okay, now remember, sine 0 is 0. Everybody knows. Sine of any multiple of pi is how much? See, sine 0 is 0. Sine pi is 0. Sine 2 pi 0. Sine 3 pi 0. Sine 4 pi 0. Sine of any multiple of pi is 0. So directly write 0 here. Into dr or equal to, see, patience required, r equal to 0 to r equal to r of 2 pi, see, 2 pi, oh no, first answer here, what is here? This r cube by 2, r cube by 2 is already there here, r cube by 2 into, see, this full term becomes 0, so into 2 pi into dr or equal to, see now. Now see, 2 pi by 2 is pi. Now variation is only r. 2 pi by 2 is pi into r cube dr becomes r power 4 divided by 4 limit 0 to r or equal to pi into upper limit r power 4 by 4 minus 0 power 4 by 4 or equal to pi r power 4 divided by 4. If you remember, same answer we got little earlier, moment of inertia about the x-axis axis, pi r power 4 by 4, right here, one result. Therefore, see, this I will remove now, okay, this I can remove. One result you write here, result. Therefore, for a circular of radius r or diameter d, you show that AB axis. You write the answer. I about AB, which later will become I about XX also. I about AB equal to pi r power 4 by 4, or substituting r equal to d by 2, we get I about AB equal to 1 by 2 power 4 is 1 by 16 into 4 is 5d power 4 by 64. And right, this IAB is actually, right, equal to IXX equal to IYY. For the original sketch is not there now. See, now right, that is here. See, for a circle, this is XX, this is YY. Whatever IAB you got is equal to IXX, but we know that IXX equal to IYY. This is for circular area. Now, 1 minute. Now do one thing, make a note. Suppose you want for semicircular area about AB, it is not centroidal, make a note here. Suppose you want for semicircular area, you write here. See, then you should put sketch only this much. See, this is the sketch you have to write. Other things are all same. Only change is, you write here, if it is semicircular, your variation of theta is 0 to pi. You write here, 0 to pi. See, if it's semicircular, you write your theta variation is 0 to pi. Okay, start from here. Other things are not required. 0 to pi means, see, pi, what happens here? Pi, 0 to r, 0 to pi, 0 to r, 0 to pi. It is sine 2 pi. Then here, minus sine 0, minus half. Where is something wrong? One term missing here. 0 to pi means one term is missing here. 1 minute. Where is the missing term? If it is semicircle, it is not 0 to r, 0 to 2 pi. It is 0 to pi. Oh, sorry. Here, see. Pi. Oh, I was wondering what to do. Upper limit is pi minus 0. Oh, 0. Again, sin 2 pi also 0. Or it will become r cube by, where is it? Pi, r pi, instead of 2 pi, pi will come here by 2. Or it is pi r power 4 by 4. Where is the answer? Pi by 2. See, it is pi by 2 r power 4 by 4 becomes pi by 2 into r power 4 by 4 is pi r power 4 by 8. That means if it is semicircular area, you make a note here of diameter equal to d or radius equal to r, then moment of inertia, it is not centered on the axis, about the base here, IAB. Your IAB equal to, this all I will explain tomorrow, equal to, in terms of radius, pi r power 4 by 8, or if we replace r by d by 2, you do it, your IAB will come pi d power 4 by 128. Why 128? 1 by 4 into 1 by 2 plus 1 to it, 1 by 4. 1 by 4 is 1 by 16. 16 into 8 is 128. Pi r power 4 by 128 is the answer. That is for semicircle. Just 1 minute now. Good. Actually, as I went there to pause, I paused the recording. Suddenly I realized why I paused. I thought of taking a rest. Why I want rest? When only 2 more minutes are there, I decided no. Now make one more note. Suppose if it is quadrant of a circle. Oh, I actually wasted my time. Editing means one extra editing now. Circle. Then you should write sketch only this much. See, only this much sketch. This is the sketch you have to write. Still call AB only, no problem. Still call AB. Everything will remain same. All your formula, ds, r, d theta, etc. same. Only change is limit of integration, you write here. Then r will vary from 0 to r only, but your theta will vary from 0 to, see, pi by 2. 0 to pi by 2. Okay. I made a mistake. Mistake means by pausing and I stopped the recording and restarted. I would have finished there only. Okay. So what this will become? Theta pi by 2. Actually. So here it is. See, r cube into half outside into 1 becomes theta minus cos 2 theta becomes sin 2 theta by 2, 0 to pi by 2. Okay. 0 to pi by 2. Then r equal to 0, r cube by 2 into pi by 2 minus 0. See, pi by 2 minus 0 here. Sin 2 pi by 2 is sin pi minus sin 0. Sin pi also 0 only. So you will get here, instead of pi by 2 now, see, 2 into 2 is what? 2 into 2 is 4. You will get 4 here. 4 pi into dr, or pi by 4 of r cube becomes r power 4 by 4, or pi by 4 of r power 4 by 4, pi r power 4 by 16 will come. Make a note. And therefore, answer. If it is a semicircle, okay, same way. I don't want to change it. Suppose it is a semicircle, remember, suppose of radius equal to r and diameter equal to d, if it is not centered on the axis. If you want I about this axis AB, your IAB in terms of radius is how much? Pi r power 4 by 16. Or if you replace r equal to d by 2, then IAB will become pi r power 4 by 256. How? R equal to d by 2. 2 power 4 is 16. 16 into 16 is 256. Okay, now over. Actually, finally what counts is our summary counts. Therefore, make a note here. If anywhere I forgot to change the something means you change it. Don't tell afterwards. See, one place 2 pi is there, you have not removed it. But I told here, when I told in the class, if I am not done, you do it. That much you can't do. Therefore, remember, tomorrow class, this will continue. If it is a circle, see, circle of radius equal to r or diameter equal to d, then this is your x-x axis. This is your y-y axis. This is ABCD. Then your I about xx equal to I about yy equal to, just now we got in terms of radius, pi r power 4 by 4 or pi d power 4 by 64. We got the answer. Whereas if it is a semicircle, right here, you should write it, of radius equal to r or diameter equal to d, then your I about base, it is not what? It is not your centroidal axis. If you call this axis as AB, your IAB equal to pi r power 4 by 8, pi r power 4 by 8, or if you want diameter, pi d power 4 by 128. And lastly, right here, this only right here, or right here, if it is quadrant of a circle of radius r and diameter d, then I about this AB and also I about this axis is in terms of radius pi r power 4 by 16, or in terms of diameter pi d power, see, pi d power, okay. Sometime it happens, see. What happened? I forgot to change it. That much common sense required for a student. Someone will tell, he has not changed R to D. Then what you are doing, you do it. I will get angry on him then. So much I explained, I changed the number, I forgot, I wrote replace R by D by 2. Then R will change over to D. If you find fault for such things, you don't study from me, you study somewhere else. Or study from that person who commented there, that I don't know anything. You search for him and study from him. See how much you will improve. See, sometimes human nature, when I change something, some changes I may forget to remove. But I will tell in the class, if I forget to remove, you remove it. I am not telling angrily. Such people I become angry. If it is a college class, I will tell, get out. Sorry, you still wrote R. You write D, I will tell what you told. Who is studying and who is teaching? This much effort I am putting, and you are finding a fault which is not technical, forgetting to change over. Cannot you do that one? Sorry, sir. Then, okay. Don't be sorry the next time like this. Okay. So this is the answer. This I require for tomorrow. Tomorrow means next class. Today's class, do one thing. You go to approach 1. That's the easiest approach. Approach 2, I did first. Taking a circular strip is the best one. You do that one. These all I will write in the summary. Actually, next class is very, very important. I will tell you moment of inertia of a circle, about centroidal axis, of semicircle also. See, about the centroidal axis here, and quadrant also, I will tell centroidal axis, which is the most important. Why? We always want IXX, IYY. Okay, we'll meet in the next class. Thank you.